Another classical situation where the force is not a constant force but depends on x is when we're looking at forces needed to stretch or compress a spring. And that's Hooke's law. The force it takes to stretch or compress a spring x units of length from its natural length is proportional to this number of units of length. In other words, F is of the form kx, where x is how much you compressed or elongated the spring from its natural length, and k is a constant that depends only on the spring, and we call that the spring constant. You see on the picture above that what x represents here. So let's look at an example involving such a spring. In this case, our spring has a natural length of 1 meter, and we know that a force of 24 Newton stretches the spring to a length of 1.8 meters. In other words, 24 Newton produces an elongation of 0.8 meters. First, we want to find the spring constant. And that's easy because if an elongation of 0.8 meters is produced by a force of 24 Newton, then K is the magnitude of that force divided by the elongation, according to Hooke's law. And therefore, it's 24 divided by 0.8, it is 30. The unit for that is Newton per meter, because we divide a force by a distance. The second question is to find how much work it would take to extend this spring from its natural length to a length of 2 meters. And we've seen that the work, if we're employing a variable force, which is going to be the case because according to Hooke's law, the force to stretch out a spring is going to depend on how much already elongated the spring is. This work is going to be obtained by simply integrating the force from A to B if we move the body from A to B. So in our context, the force is of the form Kx, where K has been established to be 30. So we integrate 30x from 0 to 1. From 0 because we're looking at what happens when we extend it from its natural length, corresponding to x equals 0, to a length of 2 meters, corresponding to x equal 1, because it's going to be 2 meters if the elongation is 1 meter. Now an antiderivative of 30x is 15x squared. We evaluate that between 0 and 1, and therefore we get 15 joules for the work needed. The third question is to know how far would a 5 kilograms mass attached to the spring stretch it. If we attach a 5 kilograms mass, the force exerted is, or at least its magnitude, is simply the weight, which is the mass multiplied by acceleration of gravity, which in this video we have picked to be 9.8 meters per second squared. So if I multiply 5 by 9.8, I get 49, so the force exerted is 49 Newton. But that should be of the form 30x because we're looking at a spring for which Hooke's laws apply, and the spring constant has been found to be 30. So we solve for x, and x is 49 divided by 30, which is 1.63, and we obtain it in meters. In other words, a 5 kilogram mass stretches the spring 1.63 meters from its natural length, in other words, to a length of 2.63 meters, since the natural length was 1 meter. Now turn to some homework before you take this second sample quiz and then quiz.